Hello students, welcome back to our exciting series where we are solving previous year questions topic wise. Today in this class we are going to solve previous year JEE Mains questions of January 2025 and 2024 attempt, specifically of motion in one dimension, or you can also call it motion in a straight line, right students? So I hope you know the theory. Now without wasting any time, let's get started. The first question is from 29 January shift 2 attempt. Again reminding you, pause the video, try the question yourself first and then go for the video solution. Alright students, so the first question is from 29 January shift 2. Two cars P and Q are moving on a road in the same direction. Acceleration of car P increases linearly with time, whereas car Q moves with a constant acceleration. Both cars cross each other at time t is equals to 0 for the first time. The maximum possible number of crossings, including the crossing at t is equals to 0, is. First of all, since we are talking about Q with respect to P or P with respect to Q, as we are talking about, overtaking, let's do it by relative motion. Secondly, we will of course assume the cars to be point size as we normally do, right? And the third thing that we don't know whether car Q is moving quicker or car P is moving quicker when the first overtaking is being done. Alright students, so let's start off with this. So let's first assume that this car Q is having a velocity uq forward, whereas car P has a velocity up forward. So I am assuming case first that car Q is moving quicker than car P for the first time, and let's take this point as the point of overtaking, that is the relative separation is 0. So let's take this as the origin of relative motion, right? What about the acceleration? So acceleration of Q is like AQ, that is like A, and the acceleration of P is like AP, and that is like KT. So it is of course increasing with time. So the relative velocity here is going to be UQ minus UP, and that is like let's assume that that is U. Since we have assumed that UQ is greater than UP, so the relative velocity initially is forward, and acceleration of Q with respect to P of course is going to be A minus KT, assuming this acceleration is going to be positive initially, but with time this will keep on decreasing, and after a point this will also become 0 and then will become negative, right? So every time this relative separation becomes 0, that is it passes through the origin, we will say the overtaking is being done or they are crossing each other in a way, right? So this acceleration is like A minus KT. So initially this point is going to move forward, but this acceleration will keep on decreasing, so the velocity will still increase but at a lower rate. Now at one point acceleration will become 0, and after that acceleration will become negative, and we would say that retardation is going to happen, and after a point velocity will become 0, and this point is going to pass through the same starting point, that is the origin. So 1 crossing the starting one and 2 crossing, so according to this answer should be 2. But there is another case that is possible, since they have not given whether Q is moving quicker or P is moving quicker. So case 2, if I take it like that let's say velocity of Q is less than velocity of P initially. Now listen to this very carefully. So now what's going to happen is that initial velocity will be towards the left, while the acceleration will be towards the right at a value A minus KT. Now listen to this very carefully. So this is representing the relative separation, and its value is 0 at the first point, and now what happens is this has a relative velocity to the left but acceleration to the right, hence the velocity will keep on decreasing, and at a point the velocity will become 0 and this will take a U-turn, right? So we would say like this, okay? So it will start off like this, it happened here like this, and now it is like first crossing and then second crossing. Now listen to this very carefully. This term will keep on decreasing obviously because time is increasing, and at one point it will also become negative. So when it will become negative, we would say the acceleration will again reverse to the left, and we would say that it will cross the same point or the origin again. So it is like the third crossing. So in a way the relative separation becomes 0 3 times including the first one, and since we have to give the maximum possible number of crossing, the answer should be 3, my dear students. So quite a wonderful question, I must say, because you need the concepts to be really correct or really strong to understand how this is happening. So the best way I thought of doing it was through relative motion, and whenever the relative separation becomes 0, we can say that this relative separation will become 0 3 times, 1, 2 and 3. All credit goes to the fact that acceleration will reverse the sign also in between. So initially the velocity was to the left while the acceleration was to the right, and hence retardation happened, and after a point it returns back, and then again the acceleration reverses its direction, and hence it crosses the origin one more time, right? So think about it, and let me know in the comments if you did not understand. We have multiple ways of doing the same question, so we'll come up with another solution, right? So copy this down, then we move on to the next one. All right, students, so the next question is from 29 January shift 1, the maximum speed of a boat in still water is 27 kilometers per hour. Now this boat is moving downstream in a river flowing at 9 kilometers per hour. So it's just a way of saying that the boat is going to have a speed of 36 kilometer per hour because it's going downstream. So the river velocity is going to add up in the boat velocity, and hence we can also write it as 36 into 5 by 18, and that's like 10 meter per second. So first I've converted this to meter per second, right? A man in the boat throws a ball vertically upwards with a speed of 10 meter per second, but of course the man is also moving with the boat, so even if he throws the ball upwards, the horizontal velocity will still be gifted to the ball, as you may know, and therefore we would say that ball will actually follow this path only. But the good part is that this velocity of 10 meter per second that the boat is possessing, the ball will also have the same velocity. So ultimately, if we are only talking about the range of the ball as observed by an observer at rest on the ground, things become really easy for us. We will first of all use time of flight, that is going to be 2 uy over g, and uy is like 10. So the time of flight is going to be 2 into 10 divided by 10 because gravity has to be taken as 10. So it's like 2 seconds. And now if we talk about the range, so range is going to be simply ux into t, and ux is like 10 and time is like 2 seconds. So the range is going to be 20 meter as well, right students? So we have to talk about the range of the ball as observed by an observer at rest on the river bank is this much centimeter. So if it is like centimeter, then you can of course convert it to centimeter by multiplying it by 100, and in that case the answer is going to be 2000 centimeter, right students? Copy this down, then we move on to the next one. Right, so the next question is from 28 January shift 2 2025. The velocity versus time graph for an object moving along a straight line is shown. What is the distance covered by the object between t is equals to 0 to t is equals to 4 seconds? Right, so we are talking about the distance traveled from t is equals to 0 to t is equals to 4. So we are only concerned about this particular area. So velocity versus time graph, area under the curve gives us the distance, so no problems whatsoever. And the velocity is not even reversing the sign, or we would say the body is not reversing its direction, hence distance and displacement both would be the same, right students? So let's just calculate the area under the curve. So it's going to be like area of this triangle, so this is going to be half into 10 into 2 for the triangle part, and then it is going to be 10 into 2 for the rectangular part. Be careful that you only have to talk about 4 seconds, so don't go beyond that, and hence the answer is going to be like 10 plus 20, and the answer is going to be 30 meter, right? So the correct option should be option A, my dear students. Right, so the next question is from 23rd January shift 1 attempt of 2025. The motion of an aeroplane is represented by velocity versus time graph. The distance covered by the aeroplane in the first 30.5 seconds. Again, a very similar question, just calculate the area under the curve. So area under the curve will be calculated in two parts. Let's first calculate the area of the trapezium. That is going to be half into sum of parallel sides is like 200 plus 400, that is 600, into the distance between them, that is like 2 seconds, and then the aeroplane is cruising with a constant velocity of 400, and that will happen from 2 to 30.5, that is another 28.5 seconds, right students? So 2 and 2 cancels out here. So this is like 600, and this is going to be 4 into 28.5 is like 114. So it's like 11400. So when we add this up, of course, the area is going to be 12,000. So 12,000 meter is like 12 kilometer, right? So since we have to give the answer in kilometer, can't get easier than this. The correct answer is option A, my dear students. Right, so the next question is from 9th April shift 2 attempt of 2024. Two cars are traveling towards each other with at a speed of 20 meter per second each, all right? So they both are traveling towards each other with a speed of 20 meter per second. Now we can visualize this. Okay, when both the cars are 300 meter apart, both the drivers apply brakes and the cars retard at the rate of 2 meter per second square the distance between them when they come to rest. So let's just calculate, how much one car would travel. Because of symmetry, we can say the other car would travel the same distance in the opposite direction, right? So before it comes to rest, so of course, since it's a constant acceleration, uniform acceleration, let's just use the equation of motion. Can't get easier than this. V is 0, u is how much, my dear students? So it's like 20, and since it's retarding with a acceleration of -2, so the displacement of 1 turns out to be 400 divided by 4, that is like 100 meter. So this car will also travel 100 meter, and this car will also travel 100 meter, and since initially they were like 300 meter apart, so 100 and 100, so the remaining distance will also be 100 meter, right, students? So the distance between them when they will come to rest is going to be 100 meter. Right, students? So the next question is from 2024 9th April shift 1. A particle is moving in a straight line, covers half the distance with a speed of 6 meter per second. So let's assume that this distance is x. So for the half the distance, that is, let's say x by 2, it's traveling with an average speed of 6 meter per second, while the other half it's traveling with 9 and 15 in equal time intervals. All right, my dear students. So let's say for time t it is traveling with 9, and for time another t it's traveling with 15 meter per second. And now we have to talk about the average speed. We have done so many questions like this, can't be difficult for us. So let's just calculate the average speed. So that's going to be the total distance divided by the total time. Okay, so the time for the first half is going to be x by 2 upon 6, and for the next half it's going to be like t plus t, and that is like 2t. Okay, so that equal interval of time, I've assumed that it's t. So we can write that 9t plus 15t is equals to x by 2, isn't it, my dear students? So what I have done is distance is equals to speed into time. So this distance plus this distance should add up to become x by 2, and hence it's going to be like 24t is equals to x by 2, or we can write 2t is equals to x by 24. Now I have the value of 2t. Let's plug in it in this expression. So the average speed is going to be x upon x by 12 plus x by 24 for this one. And now if we take the LCM, so it is going to be like 24 into 12 divided by 36. X factor will cancel out, and this is like 3 times, and this is like 8 times. So the correct answer should be 8 meter per second. So the answer is option B. Very easy, very straightforward, no problem whatsoever. All right, so the next question is from 8th April shift 1. A clock has 7 centimeter, 60 centimeter long seconds hand and minute hand. Okay, in 30 minutes duration, the tip of the second hand will travel distance x more than the tip of the minute hand. The value of x in meters is nearly. All right, so a clock has 75 centimeter long second hand. So first let's calculate how much seconds hand will travel, and they are talking about the distance and not the displacement. So it is like 30 minutes. So the seconds hand will complete 30 revolutions, right? So 30 into 2 pi r is what we are talking about. So 30 into 2 pi, and what about the length of the seconds hand? So it is like 75. So it is going to be how much, my dear students? 75 into 2 is like 150. 150 into 3 is like 450. So it's like 4500 pi and this is in centimeter, so let's convert that to meter. So it's going to be 45 pi meter. So that's about the seconds hand. Now let's talk about the minutes hand. So minutes hand in 30 minutes is going to cover half a revolution, right? Because minutes hand will cover one whole revolution in 1 hour. So 30 minutes is like half of that. So the distance traveled by it is going to be pi r dash. So where r dash is going to be how much? So it is going to be 60, right? And since it is centimeter, so it's like 100 divided by 100, so it's like 0.6 pi meter, right? So let's calculate the approximate value. The options are a little close here, 139.4 and 140.5. So let's be a little more careful. So this is going to be like, if we subtract the two, so this will become 44.4 pi, right? So this will be like 44.4 into 2 pi by 7, so like 2 pi by 7, so it's like 3.14. So let's take it as 3.1 approximately, or let's say 3.14. Then we will have to multiply the two. Let's do it really quick. I will use the calculator here. So it is going to be 44.4 into 3.14, and what I'm getting is 139.4, my dear students. So the correct answer here should be option C, right? You can do this calculation yourself. I just wanted to save time, right? Okay, the next question is from 6th April shift 2 attempt. A body is projected vertically upwards with a certain speed from the top of a tower, reaches the ground in time t1. All right. So this is projected upward such that it reaches the ground in time t1. Let's say it's projected upwards with a speed u. Okay, it's simply motion under gravity. And the other one is projected downwards from the same tower with the same speed, and it takes time t2, right? And a time taken to reach the ground if it is dropped. So initial velocity in the third case is like 0. So if initial velocity is 0, it takes time t to reach the ground. We have to relate t, t1 and t2. We always take this question in our theory classes. Still, let's do that real quick. A, B and C. So let's write the equation for A and B first, taking the upward direction as positive and the height of the tower as h, right? So I will use the equation S is equals to ut plus half at square, because that's what is going to relate displacement and time. So for A, I'm going to write S is like minus h is equals to ut1 minus half g t1 square. While for B, I'm going to write minus h is equals to minus ut2 minus half gt square. All the terms are negative because upward is taken as positive. So let's equate the two. So ut1 minus half gt1 square is equals to minus ut2 minus half gt2 square, right? So this will give us ut1 plus t2 is equals to half g t1 minus t2 into t1 plus t2. I've used the identity of t1 square minus t2 square. Okay, so t1 plus t2 and t1 plus t2 cancels out, and this gives me the value of u as g by 2 into t1 minus t2. Of course, I needed the value of u. Now I will put it again in this equation. First, let's remove the minus sign because all the terms are negative. So h will be, instead of u, I will write g by 2 t1 minus t2 into t2 minus half g t2 square. Right, my dear students? So half g t2 square and half g t2 square will cancel out. Why? Because one term would be positive and the other term would be negative. This is plus. I've removed the negative sign, right? So all three terms were plus. So the value of h turns out to be half g t1 t2, right? So I have calculated the value of h in terms of t1 and t2. Now if I write the equation for C, so what is it going to be? S is equals to ut plus half at square. S is again minus h, u is like 0, and this is like minus half gt square. So h turns out to be half gt square, and this h is half gt1 t2 as well. So let's equate the value of half gt square with half gt1 t2, and of course it's very simple now. That value of t turns out to be under root of t1 t2. So the correct answer is option A, my dear students. I think that there should be no problem whatsoever in solving this. It's only about, just maintaining the temperament, maintaining the confidence while you're applying the equation, and being careful that you don't mess up with any of the signs, right? Alright, so the next question is from 6th April shift 2 attempt of 2024. A particle moves in a straight line so that its displacement x at any time t is given by x square is equals to 1 plus t square. Its acceleration at any time t is proportional to x raised to the power minus n, where n is. Alright, so very simple problem. You just have to do differentiation here. So x square is equals to 1 plus t square. Let's differentiate with respect to time. So it is going to be 2x dx by dt, right? So because I'm differentiating with respect to time, so it has to be 2x first, applying the chain rule, of course. Differentiation of 1 is going to be 0 and t square is going to be 2t. So 2 and 2 cancels out, and this can be written as v, my dear students. So xv is equals to t is what we know. Now if you want acceleration, you should differentiate this again. So if I differentiate this using product rule, I will keep x as it is, then I will differentiate v, then I will keep v as it is, and then I will differentiate x. And the differentiation of only t is going to be 1. So this can be written as x into a, and this is again v into dx by dt is again v, so we can write it as v into v is v square. So x into a is equals to 1 minus v square, very simple. So a is equals to 1 minus v square upon x. But v itself is a function of x, and we can always replace v by t by x. So this is going to be 1 minus t by x square divided by x. So we have an x square in the denominator, and another x will make this a proportional to x raised to the power minus 3 or 3x cube in the denominator, and hence if we compare it with x raised to the power minus n, then the value of n that we have to fill in is going to be 3. Right, my dear students. So the next question is from 6th April shift 1 of 2024. A train starting from rest first accelerates uniformly up to a speed of 80 kilometers per hour for time t. Okay, so we are very tempted to draw a graph here, of course. So first it is accelerated uniformly, right, and in time t it acquires a speed of 80 kilometer per hour is what we know. And then for another time 3t, it keeps on moving with that constant speed of 80 km per hour. So this time is going to be 4t in total if this is like 3t. The average speed of the train for this duration. So that's very easy, students. Let's calculate the area that will give us the total distance traveled. So the distance s is going to be half into 80 into t is for the first part, plus 80 into 3t is for the second part, right? Because the second part is just a rectangle. So this is going to be 40t plus 240t, and that is going to be like 280t. So that is like the distance. Now let's divide the distance by the total time. So average speed, my dear students, is going to be 280t. Be careful, the total time is not t, it is going to be 4t. So 280 divided by 4 will give us 70 kilometers per hour. So the correct answer here in kilometer per hour should be 70, my dear students. I hope you've understood this. There should be no problem. Right. So the next question is from 5th April shift 1. A body moves on a frictionless plane, okay, starting from rest. Okay, so this is frictionless plane. That means it will accelerate uniformly. Okay, initial velocity is of course 0, starting from rest is what they have given to us. And if Sn is the distance between t is equals to n minus 1, so that's like nth second. And Sn minus 1 is the distance between n minus 2 to n minus 1, so that's like n minus 1th second. So it is very easy, we just have to use the expression for Snth. So Snth is going to be 0 plus a by 2. So the formula is u plus a by 2 into 2n minus 1. So it's going to be like a by 2 into 2n minus 1, right? And for Sn minus 1th, what I will do is I will put, instead of n, I will put n minus 1. Of course, you know that. So they have given to us that Sn minus 1 over Sn. So I have to divide this by this. So what I am getting here is 2n minus 2 minus 1. So it's like 2n minus 3, right, dear students, divided by 2n minus 1. Okay, so I have to represent it in this particular format. So what I can do is I can write this as 2n minus 1 minus 2, isn't it, divided by 2n minus 1, right? So this will become 1 minus 2 divided by 2n minus 1. So it's just you have to manipulate things here. Okay, so this is like 1 minus 2 by x. If I compare this with this term, right, so what I can clearly see is that x is equals to 2n minus 1, right? Then for n is equals to 10, the value of x is. So if I put n as 10, this becomes 20 minus 1, and that is going to be 19. So it's quite a simple, quite a straightforward problem, just that you need to be very careful while you are using the equation, and I hope you will be doing that, right? Okay, my dear students, so the next question is from 4th April shift 2 attempt of 2024. A cyclist starts from P of a circular ground of radius 2 kilometers and travels along its circumference to the point S. So from P it reaches S, the displacement of the cyclist. So from P to S, I will just need to draw a vector starting from P and ending at S. So it is like this vector. So that is the displacement. That's all you had to do. So this is like 2 kilometer. This is like 2 kilometer. Then this has to be like 2 root 2 kilometer, right? So, and the direction is going to be towards southwest if you go by the direction, right? So 2 root 2 is like root 8. So the correct answer is option A. This is like one of the simplest problem you can ever get in JEE. Right, students? So the next question is from 4th April shift 2 attempt. A bus is moving along a straight highway with a speed of 72 km per hour. We can always convert that to meter per second. Is brought to halt within 4 seconds after applying the brakes. The distance traveled by the bus. So that's quite easy, assuming uniform retardation. So it's only about using the third equation of motion. V square is equals to u square plus 2as. V is like 0 and u is like 20 meter per second. Why? Because 72 into 5 by 18. A is a uniform retardation. We don't know what it is, and the displacement S is what we have to calculate. Now we can always calculate that retardation by using the equation V is equals to U plus AT. So V is like 0, U is like 20, A is what we don't know. Let's assume it's like minus A, and time is like 4 seconds. So A turns out to be 5 meter per second square in magnitude. So let's plug in this value. So this is like 20 square is equals to 2, and acceleration is like minus 5. So this is going to be like 2 into 5 into S. So S turns out to be 400 divided by 10. So this is like 40 meter, right? So that's all we had to answer. So the correct answer here should be 40 meter, my dear students. All right, so the next question, this is from 4th April shift 1 attempt of 2024. A body travels 102.5 meter in the nth second and 115 meter in the n plus 2th second. The acceleration is. All right, so we just have to apply equation of motion of s nth. So it's going to be u plus a by 2 into 2n minus 1. So that is given as 102.5, my dear students, right? The next part is like Sn plus 2th. So we'll apply the same formula. Instead of n, we will replace it by n plus 2. Right? So it's going to be 2 into n plus 2 minus 1, and that is like 115. Okay, so let's do one thing. Let's equate the value of u from both the equation, and that will give us the value of acceleration, of course. So 102.5 minus a by 2 into 2n minus 1 is equals to 115 minus a by 2 into 2n plus 4 minus 1 is going to be 2n plus 3, my dear students, right? So 115 minus 102.5 is going to be 12.5, of course, yes, and that is equals to a by 2. The term of 2n and 2n will cancel out, and what are we left with? 3. Okay, so this is like 3, and this will become how much? So this will become 3 plus 1, that is 4. and when we divide it by 2, so we are getting 12.5 is equals to 2a. So the value of a turns out to be 6.25 meter per second square. So the correct option is option A, my dear students. So fairly easy, you just had to apply the equation of motion that you of course know, and then you have to solve the equation for A. So we don't need u here because the term of u is eliminated, and that is why you're able to get the value of A, because the term of n also cancels out at the same time. Copy this down, then we move on to the next one. Alright, now let's move on to the next one. Is from 1st February shift 2 attempt, a particle initially at rest starts moving from reference point x is equals to 0 along the x-axis with a velocity v that varies as v is equals to 4 root x. The acceleration is very easy, very straightforward. We do understand since its s is in the x direction, we can write a is v dv by dx, right? A is v dv by dx. So all we need is dv by dx, right? So let's plug in the value of v, that's like 4 root x. So dv by dx is going to be 4 into root x, differentiation is going to be 1 by 2 root x. So this becomes 2 by root x, that is the value of dv by dx. Now plug in the value of v is like 4 root x and dv by dx is like 2 by root x. Root x cancels out and the acceleration turns out to be 8 meter per second square. Can't get easier than this. Right, students. So the next question is from 1st February shift 2 attempt of 2024. Train A is moving along 2 parallel rail tracks towards north with speed of 72 km per hour, and train B is moving towards south with a speed of 108 km per hour. Okay, so train A is moving towards north with a speed of 72 km per hour, while train B is moving towards south with a speed of 108 km per hour. Velocity of train B with respect to train A and velocity of ground with respect to train B are. Okay, so we have to talk about velocity of B with respect to A. So let's use the I cap J cap notation here. So we can write velocity of B in meter per second. So it's going to be 108 into 5 by 18, right? 108 into 5 by 18. So this is going to be 6 times. So this is going to be like 30. And the direction of B is going to be minus J cap. Let's not hurry up with things and do it very carefully. Now what about velocity vector of A? So velocity of vector of A is going to be 72 into 5 by 18. So it's going to be like 20 J cap, right? So now first we are talking about velocity of B with respect to A, right? So that's going to be velocity of B minus velocity of A. So what is velocity of B, my dear students? So it's like minus 30 J cap, and velocity of A is like 20 J cap. So this will turn out to be minus 50 J cap. That's velocity of B with respect to A. Now velocity of ground with respect to B is also what they are asking. So that's going to be velocity of ground minus velocity of B. Velocity of ground is like 0 and velocity of B is like minus 30 J cap. So this turns out to be plus 30. So with the sign, the answer is going to be minus 50 and plus 30. So the correct option should be option C, my dear students. I hope you should be able to do that. There should be no problem whatsoever. You just need to know velocity of B with respect to A is velocity of B minus velocity of A. Right, students. So the next question is from 1st February shift 1. A particle is moving in one dimension under the action of a variable force, alright. Its initial position was 16 meter right of the origin. The variation of position x with time is this, where x is in meter, okay. So the variation of its position with time is given. The velocity of the particle when its acceleration becomes 0, alright. So x is like minus 3t cube plus 18t square plus 16t is what they have given to us. This is the position, right? So v is going to be dx by dt, of course we know that. So that is going to be like minus 9t square plus 36t plus 16, right? and acceleration is going to be again differentiation of this, so it is going to be dv by dt, so that is going to be minus 18t plus 36, right students? So now let's equate this to 0 because that is what they are talking about, that what is the velocity when the acceleration becomes 0. So acceleration becomes 0 at t is equals to 2 seconds. Now plug in the value of t as 2 here, so let's do that very carefully. So this will become 2 square, that is 4, and this is becoming 72 plus 16, right students? So this is like minus 36 and this is like 16, so 8 and like 8, so 88, right? So this is going to be 88, okay, and minus 36. So from 8 if we subtract 6 we are going to get 2, and from 8 if we are going to subtract 3 we are going to get 5, right? So the velocity when the acceleration becomes 0 is 52 meter per second. I don't know what was the problem. There is no problem in this question. You just need to differentiate it twice because you're wanting to relate position with acceleration. So of course you differentiate it once, you get velocity, you differentiate it again, you get the acceleration, right? Alright, so the next question is from 31st January shift 1 attempt. The relation between time and distance is t is equals to alpha x square plus beta, where alpha and beta are constants. We've done this so many times in our classes also. The relation between acceleration and velocity is, so we are going to differentiate with respect to x first, so that's going to give us dt by dx. So dx by dt is velocity, so dt by dx is going to be 1 over velocity, and this is going to be 2 alpha x, and differentiation of beta is going to be 0, right? So let's write it as 1 over v is equals to 2 alpha x. Now we will differentiate again this equation with respect to time. So first we will apply chain rule. Differentiation of v with respect 1 by v with respect to v is going to be minus 1 by v square into dv by dt, that's our acceleration, and this is going to be 2 alpha dx by dt, right my dear students? So this will become minus 1 by v square dv by dt. I will straight away write it as acceleration, and this is going to be 2 alpha v because dx by dt is going to be v. So the acceleration turns out to be minus 2 alpha v cube. Can't get easier than this. So the correct option is option A, my dear students. Right. So the next question is from 31st January shift 1 of 2024. A small steel ball is dropped into a long cylinder containing glycerin. So those who don't know, it is about viscosity, the viscous force. Just like air, resistance is going to act on the ball. Which of the following is the correct representation of the velocity versus time graph? So it's very easy, students. We do understand that initially the force of gravity is going to be way more dominant. But as the velocity increases, this viscous force will also keep on increasing. This viscous force is proportional to the velocity. So what happens is initially it will accelerate downwards and its velocity will keep on increasing, and at one point this force of viscosity and this force of gravity will become equal. See, gravity, the force does not change, but viscous force increases with velocity. Air resistance increases with velocity. That is why air resistance is more crucial for objects that are traveling at very high speed, right? So at one point both will become equal and net force will become 0, or we will say that net acceleration will become 0, and after that velocity will stop changing, or we will say that the terminal speed has been achieved. So initially the velocity is increasing, but the velocity, the rate of change of velocity is continuously decreasing, and after a point the velocity will become constant. After that acceleration will become 0. So the perfect answer to this is option B. Again I will explain it to you, though you will learn about this concept in a chapter we will learn further, that is of fluid mechanics. But for now still you can have a decent idea of this, that the force of gravity is acting downward, which does not change, but the force of viscosity or the glycerin, the frictional force, you can call it like that, is going to act opposite to the direction of motion, and it will continuously increase with increasing velocity. Hence at one point both the forces balance out and acceleration becomes 0. Alright, so the next question is from 30th January shift 1 attempt. the displacement and increase in the velocity of a moving particle in the time interval of t to t plus 1 seconds are 125 and 50 meter per second respectively. The distance traveled by the particle in the t plus 2th second. Okay, so let's assume that t is equals to 0. It started off with some velocity u naught which we don't know, and in time t its velocity, let's say, becomes u, and in time t plus 1 its velocity becomes how much, my dear students? So this becomes u plus 50. So in a way, during this 1 second its velocity increased by 50. So in a way, they have just given us the value of acceleration is 50 meter per second square. Very simple, of course you understand that. And during this time of 1 second, they have given us that the displacement is 125 meter. So let's do that. S is equals to ut plus half at square. I am applying for this particular 1 second, right? So S is like 125, U is what I don't know, T is like 1 second, A is like 50, and this is going to be 1 square, right? So this is going to be like 25. So the value of U turns out to be 100 meter per second. So this is 100 meter per second here, and this is T plus 1 and then T plus 2th, right? So let's say this is T is equals to T plus 2. So during this time, the distance traveled from this to this. Okay. So what is the velocity after the end of this? So if U is 100, so this is going to be 100 plus 50. So this is going to be 150 meter per second at the end of t plus 1th second. So from here to here, another 1 second. Let's again apply the equation of motion. S dash is equals to U dash into t plus half A into t dash square, where t dash is also 1 second. So now this S dash is going to be U dash, that is the end of, you know, the velocity at the end of t plus 1 second. So that is like 150 into 1 plus acceleration is like uniform. So that's like 50 into 1 square. So S dash turns out to be 150 plus 25. So the correct answer should be 175 meter, my dear students. No problem whatsoever. Just be very careful which 2 points you are choosing to apply the equation of motion, the starting point and the end point. So I will explain that again to you. So these were my 3 points which I was majorly worrying about. So t is equals to 0. It started off with some velocity we don't know. At tth second, the velocity became u. At t plus 1th second, the velocity becomes u dash, that is like u plus 50, right? So that means in 1 second the velocity increased by 50. Hence the acceleration is also 50, because acceleration is the rate of change of velocity, right? So I hope you are able to understand this one. Let's move on to the next one. Okay, so the next question is from 29 January shift 2. A particle is moving in a straight line. The variation of x as time with time is this. The velocity of the body when its acceleration becomes 0. We've done this so many times now. So let's differentiate this once to get the value of velocity, or the function of velocity rather. So that's like 3t square minus 12t, okay, plus 20. Now acceleration is going to be dv by dt. So if acceleration is dv by dt, so that's going to be 6t minus 12, and let's equate it to 0. So t is equals to 2 seconds is what they are talking about. Now let's plug in the value of t again in the velocity function. So this is going to be 3 into 2 square minus 12 into 2 plus 20, right? So this is going to be 3 into 4, 12 minus 24 plus 20. So this is going to be like 32 minus 24. So is like 8 meter per second, right? So the correct answer is option B. Right, students. Next question is from 29 January shift 1 attempt. A body starts moving from rest with constant acceleration, covers S1 in first t minus 1. So S1 is like u plus a by 2. Okay, no. Yeah. So we can write S1 is the displacement in the first p minus 1 second. So let's put u as 0. T is p minus 1 plus half into a into p minus 1 whole square. So this is like S1 is a by 2 into p minus 1 whole square, right? Just use the equation of motion. And S2 in the first p seconds, okay? So similar fashion, it is going to be a by 2 into p square. Instead of t as p minus 1, I have substituted as p. Then the displacement S1 plus S2 will be made in time, okay? So let's first write S1 plus S2. So that's going to be like a by 2. If we add these two, so this is going to be like 2p square plus 1 minus 2p, right? And this displacement is equated to a by 2 into t square. Let's say in time t, this displacement is made. So then the value of t turns out to be under root of 2p square, right, minus 2p plus 1. So the correct option here should be option D, my dear students. Just apply the equation of motion and nothing else. In fact, so many questions we've done today which were simply the application of equation of motion, which I hope you all should be able to manage, right? Alright students, so the next question is from 27 January shift 2. A body falling under gravity covers 2 points A and B separated by 80 meter in 2 seconds, alright? The distance of the upper point A from the starting point. So we have to assume that, let's say the starting point is O and the initial velocity is 0. It reaches A point and then B point. Let's say it reaches A point with a velocity, let's say V naught, and at point B it has some other velocity V. So during this time it covers 80 meters in 2 seconds, right? So first I'm going to choose A and B as starting and ending point, and I will use S is equals to ut plus half at square, right? So S is going to be minus 80, initial velocity is, let's say, V naught, t is like 2, and acceleration is like minus 10, right? And t square is like 2 square, right? So I've applied the equation between points A and B. You can also write it as minus V naught because we do know that it's going to be in the downward direction, right? So this is going to be minus 80 and this is going to be minus 2 V naught and this is going to be minus 20, right? So this is 20 minus 80, so it's going to be minus 60 is equals to minus 2 V naught. So the value of V naught turns out to be 30 meter per second. So we do understand that velocity here is 0, velocity here is 30, and they have asked us to calculate this distance x. So from O to A, what is advisable is I use V square is equals to U square plus 2AS, and instead of V I will write V naught, instead of U I will write 0, instead of A I will write minus 10, and displacement is like minus x. Okay, so let's put it as minus x. Okay, so the value of V naught is going to be 30. So this is going to be 900 is equals to 20x. So the value of x is going to be 900 divided by 20. So it is going to be 45 meter, my dear students. So it's a numerical type question. You can easily plug in 45. Alright students, so the next question. This is from 27 January shift 2. A bullet is fired into a fixed target, loses 1/3 of its velocity after traveling 4 centimeters. So it loses 1/3, that means it retains 2u by 3, right? If u is the starting velocity. It penetrates further this much distance before coming to rest. The value of d is, we have done this question so many times. Let's say the starting velocity was u when it just started penetrating, and it became let's say 2u by 3 at B after traveling how much distance? 4 centimeter. Now till C its velocity becomes 0, and this distance is given to be d into 10 raised to the power minus 3 meter. So let's do it very quickly. So from A to B, first light V square. So that's going to be like 2u by 3 whole square is equals to u square plus 2a. Let's write it as minus a. And the displacement is going to be 4 into 10 raised to the power minus 2. Let's convert that to meter. So this gives me u square minus 4u square by 9. So that's like 5u square by 9 is equals to 8a into 10 raised to the power minus 2, right? So this is the first equation that I have. Now I will write the same equation but from B to C. So final velocity is going to be 0, as you may clearly see. Initial velocity is like 2u by 3 whole square plus 2 minus a, and the displacement during this time is given to be d into 10 raised to the power minus 3, right? So let's put in the value. So this is like 4u square by 9 is equals to 2, and for the value of a, I'm going to put 5u square, listen to this very carefully, divided by 8 into 9, okay, into 10 raised to the power minus 2, my dear students, right? So I have substituted the value of a here, and this is like d into 10 raised to the power minus 3. So now all I need is the value of d. So u square cancels out, 9 cancels out, and this is like 4 times. So the value of d is turning out to be 160 divided by 5, right? 160. So 4 into 4 is 16, and there's one more term of 10. So 160 divided by 5. So that is like 32, my dear students. So I hope it's very easy. You just have to apply equation of motion. Right. So the next question. Next question is from 27 January shift 1. Position of an ant moving in YZ plane is given by S is equals to 2t square j cap plus 5k cap. Alright. The magnitude and direction of velocity of the ant at t is equals to 1. So velocity is very easy. ds by dt. So this turns out to be 4t j cap. Differentiation of 5 is going to be 0. So when t is 1, so it's like 4 meter per second in the positive y direction, right? Positive y direction. So the correct answer should be 4 meter per second in the y direction. That's option D. Alright students, so the last question of today's class of 27 January shift 1 attempt. A particle starts from origin with a velocity 5 I cap meter per second and moves in the xy plane such that its acceleration is 3 I cap plus 2 j cap. If the x coordinate of the particle at the instant is 84 meter, then the speed of the particle at this instant is root alpha, then the value of alpha is. So clearly, let's divide everything in x and y. Initial velocity in x direction is like 5 meter per second, while the initial velocity in y direction is like 0. Acceleration in the x direction is 3 meter per second square, while acceleration in the y direction is 2 meter per second square. Now they are talking about the speed. So let's first use, of course, the equation of motion in x direction. So vx square is equals to ux square plus 2a x into x. So that is the third equation of motion in the x direction. So vx square is equals to ux square. So that is like 5 square plus acceleration is like 3 in the x direction only, students. Don't look at the y direction right now. And the displacement in the x direction is like 84. So this is going to be vx square is equals to 25 plus this is going to be 504, 6 times 84. And this is going to be vx square is equals to 529. So vx is going to be 23 meter per second. So far so good, no problem whatsoever. Now we can calculate the time. See, x and y are independent of each other, but one thing that relates both of them is the time. So let's write vx is equals to ux plus axt now. So vx is like 23, ux is like 5, ax is like 3. So this is going to be like 18 divided by 3. So the time is going to be 6 seconds, right? So now we can use this 6 seconds to calculate Vy. So it's going to be Uy plus Ayt. Uy is like 0, Uy is like, Ay is like 2 and T is like 6. So this is going to be 12 meter per second in the Y direction. So finally the answer is going to be under root of Vx square plus Vy square. So that's going to be under root of 23 square plus 12 square. So that's going to be like under root of 529 plus 144. That's clearly under root of 673, right? Yeah, 673. So the correct answer should be root alpha. So the value of alpha is like 673. I hope you should be able to understand this one. Again, just equation of motion is what you had to apply. Right, students? So I hope these videos are helping you, and if you've done this chapter, this video should really give you the confidence, because most of the questions were really very simple and you should be able to handle them if the concepts are clear and you have the confidence to go with the flow of the solution. Right, students? Do let us know what else do you want us to do to ace your exam that can help you to ace your exam. we will be more than happy to help you out, and I will see you very soon with more such video. But that's all for this one. See you next time. Bye bye. If you enjoyed this video, please don't forget to like, share and subscribe to our channel.